Hi, my name is Aldona Wiacek. I'm an associate professor of environmental science at St. Mary's University. I also hold a cross appointment in astronomy and physics. So at St. Mary's University, in my research, I'm interested in exploring the human impacts on the atmospheric environment. And I study trace gases in the atmosphere related to air pollution and climate change. So coming to St. Mary's, you could be doing work with me at the atmospheric observatory that we run, which makes long-term measurements of trace gases, which are necessary for informing policies related to air pollution control and also greenhouse gas emissions controls. So in terms of the big picture environmental issues, I am very passionate about communicating and teaching about anthropogenic, so that is human-caused, climate change. It is fascinating to me the level of public acceptance or disbelief about climate change. While in science it's a settled issue, we have 50% of the population in the US and in Canada who really don't believe the science and are confused by how humans could be responsible. And so to me, the need for teaching the physical principles behind climate change and how simple it really can be just does not go away. So I'm also passionate about transboundary pollution transport, and also as related to both air pollution and greenhouse gases. Air pollution and greenhouse gases, once emitted into the atmosphere, they really don't care about our geographic boundaries. And in Nova Scotia, we live in a funny spot where we are in the pollution outflow region for all North American pollution. But that's not the end of the train. So our pollution goes to Europe, European pollution goes to Asia, and Asian pollution comes full circle back around across the entire Pacific to meet us back in North America. So on any given day, pollution in Halifax has a significant component from other parts of the globe. And we study that and inform policy again on bilateral agreements to regulate pollution emissions and also greenhouse gas emissions, which is a global problem that involves global cooperation, such as the Paris Agreement. So at St. Mary's University, I teach a very clear line of courses. So in first year, I teach physical processes in the environment, which teaches our students about how fluid flows in the atmosphere, because as I said already, that's really relevant to pollution transport. But also, how does a CO2 molecule trap that infrared heat that we keep hearing so much with the climate change problem? And this kind of knowledge informs us later, as in second year, students learn about energy and resource use and how that leads to pollution. And in fourth year, we move on to the physical principles of climate change. And to me, that's a coherent chain of teaching material, because the climate problem is in fact an energy problem. And the energy problem is in fact a physical science problem. So we have come back around full circle. I really enjoy teaching undergraduates in our small classes at St. Mary's. The relationships that I build with students from first year through to fourth year are invaluable to me. And what I love seeing too is students going on to more complicated projects like an honors project, where they can take a research question related to air pollution or climate change and study it in greater depth. I'm Aldona Wiacek, and I really look forward to seeing you in my classes and my lab.